Okay, I'm going to go through the steps of constructing a barber pole. This was a project that we've been working on in our Fusion 360 weekly class that meets in Desktop Makes every Tuesday afternoon. But anyway, let me show you what I did here. You can see I started with a sketch. So this is the outer rim of the barber pole, and this is the height of the barber pole. So it's going to be about 2 inches across and about 12 inches tall. And zooming in here, you can see I have a kind of a center cylinder here. You'll see why I have that later. It's also important to have it because I need the 4 quadrants for my barber pole spirals. So the next step after finishing the sketch, I come back and I went ahead and extruded that center cylinder 12 inches. Basically that's just an extrusion following that path. And then I came up and I made a sweep, taking one of these quadrants, and I came up to 12 inches with a 720 degree rotation. So basically using the sweep command and then coming up to the top 12 inches or up to that point, and gave it a 720 degree twist. So basically 2 turns. and then you can see I went ahead and instead of doing each sweep, I just went ahead and made a circular pattern and took the one body that I made and made 4 copies of it, or 3 copies. And then the next step, well, you can see I had bodies here, but I need to create components because I want to attach them and get them to revolve. So to do that, you have to go into the component space. So bing, 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 bing. So there are all the bodies now. And that step there is, oh yeah, now I have to go up here and I apply the joints. So I've got 4 components, and so I had to go ahead and join each one of these separate components together. So that's what that business is about there. And you can see each time I make the join that I get a little indicator that I have a rigid joint there. Then I came back in the center. I put in a revolute joint, and basically here I define this. Well, in the next step I will actually ground this center cylinder, but I'm taking the outer edge of the inner cylinder and establishing a relationship with the inner edge of the outer cylinder so that I can define a revolution. And so that's what that's about. And then I ground it. And then you can see that little symbol there that indicates that since I'm in the component space and I wanted to draw a sketch on top of it, it asked me to capture the current coordinate system, basically. And you can see I drew a sketch there, just a simple circle on top of the barber pole. And then I come up there and I extruded it about 1/4 of an inch. And then I came in and I drew another sketch. You can see here I went ahead and using the arc tool just had a point there, and then a point at the top. And I came in here with the line tool so that I could get a profile, because I want to do the next step, of course, is the revolve command, which allowed me to revolve that around. And then again I applied a mirror finish to that. And then a little cleanup here. I went ahead and you can see here I just made a little chamfer there, 1/4 inch chamfer. And then I went ahead and combined this the 2 bodies here so that they were one, because the next step is to go in and move them, that's the move command. And then you can see I didn't quite move it down far enough. That's why there's another move command. Yeah, so that's how that worked. I'll just show you quickly the motion study. I'll go in and edit that, And so I'll just go ahead and put that on a loop and then go ahead and play it. And if you had a negative number in there, I went from 0 to 100, and so I just made this 360. So you can speed it up, and then of course you can slow it way down too. It's kind of funny, it starts pretty fast, but if you go up and then down, it'll slow down nicely. So that's how that was put together.